So today's video, I am going to explain to you all what is called as optical activity. Optical what? Activity. So here under this topic we have what is known as optical activity. Now certain terms you must know to understand what is called as optical activity. One is called as asymmetric carbon. Asymmetric carbon. You can say asymmetric carbon or asymmetric carbon. Please see, understand that. Now, what is that asymmetric carbon? A carbon, you know that every carbon has 4 bonds. Every carbon. So, 4 bonds are like this, directed to the 4 corners of a tetrahedron. So, this carbon has 4 bonds. And if this all the bonds, there are 4 different group attached. Please follow. If there are 4 different group attached, let me put it here as 1Br. One group has CS3, okay. One group has C2H5, and here there is say H. Now what you can observe, please follow. On this carbon here, there are 4 different groups are present. One is this, one this, and one is this. Altogether 4. One is bromine, one is CS3, one is C2H5, and one is H. Then this carbon is called as asymmetric carbon. Okay. Now compounds which have got asymmetric carbon, they only show optical activity. So first you must know what is called as asymmetric carbon. So I will put it in general as, suppose that this is a carbon, general. And if I call this here as A, this is say B, I will not put here C, this is say Z, and this is say D. Now what you can observe here, see, this carbon is said to be asymmetric carbon. So concept should be very clear. When you have a carbon with 4 different bonds satisfied by 4 different groups, then that carbon is asymmetric carbon. Now this compound which has all the 4 bonds satisfied by 4 different groups, that compound will show optical activity. Now here one more thing, see, suppose if I have a compound which is like this, carbon with 4 bonds, okay, and so that now see, you'll understand very clearly. Suppose in this group here I have Br, okay, bromine. This group I have say CS3, okay, let me put the different color so that you can know. And this group I have here also CS3, and this I say H. Now over here if you just see this methyl group and this methyl group, let me just make it more clear. See, suppose this group is here CS3 and this group over here is say Br. Now you can observe properly that to this carbon there are 2 groups which are same attached here. Means of the 4 bonds, 2 bonds are satisfied by the same group methyl. Then this compound, this carbon is not called as asymmetric carbon or asymmetric carbon. And this compound is not optically active. This is, I am explaining to you in a simple way. See, when it can show optical activity only when the compound has 4 different groups. I'll show like this here. I'll say this compound, this shows optical or shows optical activity. So this and this, they will show optical activity. This will be not optically active, cannot show. Now, how do you know whether it will be optically active or optically inactive. We can also say optically inactive compound. Why it is optically inactive compound? Because all the four bonds here not satisfied by different group. Two groups here are found to be same, okay? Or even all the groups suppose say same, no optical activity. Now, how you define that optical activity? That is what is called as, what you must know, what is called as plane polarized light. Plane polarized light. So I will explain to you and then I will come to that part, what is called as optical activity. Plane polarized light. There are certain terms you must know. So, you see, for this part, I will just explain to you some experimental part here. Then only you will follow very well. If we have one prism called Nichols prism, okay, there is special prism which is called a Nichols prism. This is a transparent where the light can pass through. So what is actually it is like this. Suppose say a cube is taken. I'll further explain to you how that Nichols prism is. Suppose a three-dimensional figure which is like this. And over here, suppose say like this. So can you understand? This prism, this cube is cut diagonally. So if we cut here diagonally like this and like this, you will get the two pieces like this. So the two pieces, suppose say if I show one piece as I'm just showing, this is the way it will exist like this. Okay, somewhat like this shape. Similarly, you will see another piece the opposite way like this, see. Somewhat like this, see. Now these two pieces are then joined by means of certain, what is called as, just like araldite and all, you get Canada balsam. So here in between this, Canada balsam is put. So which I will show like this, okay? And actually see what happened, follow, no? This Nichols prism which is cube is cut into two pieces. Then in between this, you put the Canada balsam, which is to stick the two pieces. Of course, that Canada balsam is allows the light to pass through. Now, if this is ordinary light with number of waves vibrating in different planes. So here you can see this is the ordinary light. I will just tell you in short. If you make this light to pass to this prism, special design prism called Nichols prism, then you will see that all these vibrations which I have shown here, okay, are cut off. And this is found to vibrate in only one plane, like this. Can you now follow? See, they were having waves one way like this, one way like this, waves in different direction, planes. Now after that, if it is found to vibrate in only one plane, then that light is called as plane polarized light. This is what is called as plane polarized light. Now see, I hope you followed. Earlier it was like this, means like this, like this, like this. Followed? Different direction. But when you pass it to the Nichols prism, it is found to vibrate in only one plane. Okay? And it moves. So this light is called as plane polarized light. So this is plane. I hope you followed. Plane polarized light. Okay, if you can't see, then respond and see. Huh? Now, if you happen to pass this here to the solution of a compound which has got a symmetric carbon. So, in between here, you put one tube, and that tube is called as polarimeter tube. This is known as, see, I don't want to show here directly on the, say, board, because I could have shown that way, but I want to show you all the skill of drawing. Okay, so here in this tube, this is called as polarimeter tube, and this instrument is known as polarimeter. Polarimeter. To know whether the compound is optically active or not, that instrument is known as polarimeter. Now here, if you happen to put the solution of a compound which has a symmetric carbon, suppose say this is the solution containing of a solution of a compound. Compound containing asymmetric carbon. Okay. Now, what you will observe from here, if you just direct further, the light will pass out, and this will go like this. Okay. This is found to rotate through certain angle. See, this light, instead of vibrating perpendicular to the plane of propagation, this is found to turn in the certain direction. So I will just show one because it will create confusion. So this was the originally it was vibrating. Now here this has shifted or turned. This turning of that is by certain angle, say I will call it theta. It has moved to the certain angle from this. Now here if you put another nickel prism over here, same way you put another prism, and then this light is now made to pass through that nickel prism. Okay, and then here that is what is called as the eyepiece with a vernier scale. So if you happen to see to the, say, tube with a lens here like this, okay, and that is movable, then the small this thing is put here, and then here you can see eye. Suppose say you are looking to the eye like this. Then you will observe this rotation means what? This was seen earlier. This was seen, light was visible. But when you put this solution here, the light become invisible. Now go on rotating this. This is rotated. Okay. Now this rotation will be till this theta. So this theta here and this theta here should be same. Means this angle of rotation here, I need not show this eyepiece here, eyepiece we can say. Okay. So if you just see the rotation over here, bring that back. So when you try to rotate, as you are rotating this, then this light become again visible. See, again I'll repeat. This is the nickel prism. This nickel prism you are passing this light, ordinary light. So ordinary light. Okay. This is found to have vibration only one plane. After that, the angle of rotation is seen here. Therefore, you will not see any light over here when you come and see the side. But if you just turn this vernier scale, okay, then you will see this angle, you have to turn it till it becomes that same angle, this angle here and this angle. Then again the light becomes visible. So from that you will know how much the rotation is, or to what angle it is rotated. Okay, so such compounds are called as optically active compound. Now how to define optically active compound? See, I'll repeat it slowly so that you can follow nicely. Compounds containing asymmetric carbon or asymmetric carbon. Compound containing asymmetric carbon. capable of rotating the plane of plane polarized light. See, I am repeating, plane of plane of plane polarized light, either to the right or to the left, are called as optically active compound. Alright. So what is required first here? Asymmetric carbon, and that compound should be in a position to rotate the plane of plane polarized light. What is plane polarized light? Light having waves vibrating in only one plane perpendicular to the direction of propagation. Okay. So if it rotates in one direction to the right, then that compound is called dextrorotatory. See, that is what is called dextrorotatory. And that is what is called as levorotatory. You can write this as levorotatory as LEA only, but usually they write it here as LEE vivo. Okay. Now this is what to the left. Rotate. I'll write in short here. Rotate to the. I think better I put plane polarized light. Rotate to the what? Right. So we can say here plane polarized light rotate to the right, and this one plane polarized light rotate to the left. So this will be called as levorotatory, and that is called as dextrorotatory. So optically active compound can be dextro or can be levo. Okay. Now one more thing. If this dextro and levorotatory compound, so this compound, I will explain to you further part of this also, how many isomers and all that. See, they are called isomers of each other. If this one is rotating to the right, this one will rotate to the what? Left, like that. Okay, I'll explain to you further next video. Now, if you just mix these two in equal quantity, suppose you take 50 ml of this dextro and 50 ml of what? Levo. If you mix and if you put here, then there won't be any rotation seen. That is called as what then? That compound will be called as the optically inactive. Okay, and that is called a racemic mixture. Racemic mixture. Remember, I'll repeat again. Racemic what? Mixture. What is that racemic mixture? Equal quantity of dextro and levo mixed. The mixture is optically inactive. So, optically inactive mixture. Containing equal quantity of D and L, dextro and levo. So that mixture is called optically inactive. Okay. Now in my next video, I will explain to you all again how you get the dextro and levo in terms of different example. Okay.